The Orion Nebula isn't just another swirl of cosmic gas. It's a dynamic celestial mystery that defies everything we thought we knew about star formation. Hidden within its glowing tendrils are bizarre anomalies that leave even the most seasoned astronomers scratching their heads. From explosive stellar nurseries to unexplained gravitational ripples, this nebula holds secrets that could rewrite our understanding of the universe. Today, we're uncovering 25 of its strangest phenomena so unusual, they challenge the very laws of physics, ready to see space in a way you never have before. Let's dive in. At the very core of the Orion Nebula lies a radiant spectacle, a searing, swirling heart of light known as the Trapezium Cluster. This isn't just another bright spot in space, it's a powerhouse of newborn stars, each one blasting the surrounding gas with torrents of ultraviolet radiation. That eerie glow we see, it's the nebula's hydrogen gas screaming under the assault, ionized to the point where it emits its own luminous fingerprint. Hubble's razor-sharp images reveal tendrils of energized gas twisting like cosmic ribbons, shifting in real time as they react to stellar winds. But here's what's truly unsettling. The nebula doesn't just shine steadily. It flickers, pulses almost like it's breathing. Scientists believe this eerie rhythm comes from shockwaves rippling through the gas, triggered by the violent births and deaths of stars buried within. This isn't a static postcard from the cosmos. It's a living, churning furnace, one that might just hold the key to how stars are born. These young, scorching stars don't just light up the Orion Nebula, they dominate it. The Trapezium Cluster's most massive members unleash stellar winds so powerful, they carve cavernous voids in the surrounding gas like cosmic blowtorches reshaping a cloud. Each star pumps out ultraviolet radiation 100,000 times stronger than our suns, stripping electrons from hydrogen atoms in a relentless subatomic storm. That's why the nebula glows. It's essentially a trillion-mile-wide neon sign powered by violence. But the real shock comes when we zoom out, those delicate tendrils and pillars immortalized in Hubble's portraits. They're actually the survivors. Only the densest knots of gas withstand the bombardment, while the rest gets blasted into the void. It's a brutal celestial sculpting session happening in real time. And the most jaw-dropping part, the nebula we see today isn't permanent. Within a few million years, a blink in cosmic terms, these same stars will erode their birthplace entirely, leaving behind nothing but scattered starlight. The Trapezium Cluster isn't just illuminating the Orion Nebula, it's devouring it from the inside out, stretching across the Orion Nebula like a colossal cosmic dam. The so-called Orion Bar isn't your typical void of darkness, it's a defiant wall of survival. While most of the nebula glows under the Trapezium Cluster's relentless radiation, this dense ridge of gas and dust stands firm, absorbing the onslaught without crumbling. It shouldn't exist. By all laws of astrophysics, such a structure should have been vaporized eons ago by the nearby star's fury. Yet there it sits, a shadowy fortress in a sea of light. What makes it even stranger, the bar isn't just passively resisting destruction, it's actively reshaping the battlefield. Ultraviolet radiation slams into its surface, splitting molecules apart and triggering complex chemical reactions. This creates a bizarre transition zone where gas changes states like layers of an onion, from cold and neutral near the core to scorching and ionized at the edge. It's a natural lab for studying how interstellar matter behaves under extreme stress, revealing secrets about everything from star formation to the origins of organic compounds. Some researchers think magnetic fields act like invisible scaffolding, holding the bar together against impossible odds. Others speculate it's simply the leftover carcass of an even larger cloud, now eroded down to its toughest skeleton. One thing's certain, while the rest of the nebula flickers and fades around it, the Orion Bar remains a stubborn enigma, a testament to the universe's refusal to follow even its own rules. Looming against the fiery backdrop of the Orion Nebula, there's a shadowy figure caught mid-stride, an eerie silhouette astronomers call the Running Man. This isn't just a trick of the light. NGC 1977, as it's officially catalogued, is a sprawling dark nebula, a dense tapestry of cosmic dust so thick it blots out the stars behind it like ink spilled across the sky. What's fascinating isn't just its shape, though the human brain can't help but trace the outline of a sprinting giant, but how it reveals the hidden architecture of space. These dust clouds aren't empty voids. They're frigid factories where temperatures plummet hundreds of degrees below zero, allowing molecules to clump together in silence, unborn stars waiting in the wings. While the Trapezium Cluster's brilliance dominates the scene, the Running Man thrives in the shadows, a reminder that creation and destruction in the cosmos exist side by side. Cultures across history have projected myths onto these interstellar shapes, heroes, beasts, even deities frozen in the stars, but the real magic lies in the science. That sprinting silhouette, it's sculpted by stellar winds from nearby young stars, their radiation slowly eroding the dust like a cosmic tide wearing down a cliff. Every groove and curve tells a story of forces we're only beginning to measure. So next time you gaze at Orion, look beyond the glittering highlights. The darkness holds just as many wonders. If you know where to look, gaze up at Orion's belt and your eyes will naturally drift downward to a celestial blade hanging beneath it, sharpened by starlight. This is the Sword of Orion, a trio of stars with the nebula positioned so precisely it feels deliberate. Ancient cultures didn't just notice this alignment, they revered it. The Egyptians linked it to Osiris, god of the afterlife, while the Maya tracked its movements to predict celestial events. But the real marvel is how modern astronomy confirms what the ancients sensed. This isn't random placement. The nebula sits at the sword's midpoint like a jewel in a cosmic hilt, a region so dense with stellar activity it outshines nearly every other nebula in our sky. Zoom in with today's telescopes and the alignment reveals even deeper mysteries. The nebula doesn't just occupy the sword, it dominates it, its glow overpowering the nearby stars. Infrared observations show dust lanes winding through the sword's length like veins, funneling material toward the nebula's core. It's almost as if the entire structure was designed to feed this stellar nursery, a gravitational funnel guiding cosmic ingredients where they're needed most. Yet the most haunting detail, from our vantage point on Earth, the nebula aligns so perfectly with Orion's belt above it, the entire constellation seems to point directly toward it, a cosmic arrow saying, "Look here." Whether by chance or some unseen force, the universe has hung a neon sign in our night sky, one that's guided humanity's gaze for millennia, and the message remains unchanged. There's still so much left to discover. Tucked away in Orion's sprawling star fields, one silhouette stands out, a shadow so striking, it looks like it was carved by celestial hands. The Horsehead Nebula isn't just another dark cloud, it's a masterpiece of cosmic erosion, a delicate sculpture of dust and gas bending against the blistering radiation of nearby stars. From the moment it was first photographed in the late 19th century, this Inkai profile has captivated astronomers and artists alike, not just for its shape, but for what it represents, the fragile balance between light and shadow in the universe. Peer closely and you'll notice the Horsehead's mane isn't static, it's under siege. The nebula's jagged edges are being slowly peeled back by the solar winds of Sigma Orionis, a young, ferocious star just out of frame. This isn't a peaceful formation, it's a battlefield where gravity struggles to hold the structure together against relentless stellar fury. The dense pillars at its base may endure for now, sheltering pockets of cold molecular hydrogen where new stars could one day ignite. But time is running out. In roughly 5 million years, radiation will win this war, scattering the Horsehead's remnants across the cosmos like smoke in the wind. Yet there's hope in its impermanence. Cutting-edge telescopes like the James Webb Space Telescope are now probing these shadows in infrared, revealing glowing tendrils of gas hidden behind the dust, clues to how such structures influence star birth. Every ripple in the Horsehead silhouette tells a story, from the chemistry of its carbon-rich layers to the magnetic fields that might be slowing its destruction. It's a fleeting wonder, yes, but one teaching us how darkness, too, shapes the universe. Just northeast of the iconic Horsehead Nebula lies a spectacle that looks like the cosmos itself caught fire, the Flame Nebula. That dramatic name isn't just poetic license. NGC 2024 truly seems to blaze with flickering tendrils of orange and red, as if some celestial arsonist set the void alight. But here's the twist, there's no actual combustion. What we're seeing is a breathtaking illusion, a cosmic magic trick played by physics. The real star of the show, literally, is Alnitak, the easternmost gem in Orion's belt. This blue supergiant bombards the Flame Nebula's dense hydrogen clouds with torrents of ultraviolet radiation, stripping electrons from atoms in a process so intense it makes the gas glow like neon. Think of it as nature's version of a fluorescent sign, except this one spans over 5 light years. The darker lanes cutting through the nebula, those are ribbons of cold dust, acting like a celestial stencil that sculpts the illusion of licking flames. But there's more lurking beneath the surface. Alnitak's radiation doesn't just light up the Flame Nebula, it's actively compressing pockets of gas inside, triggering the birth of new stars. Infrared telescopes reveal dozens of protostars buried in the dust, their faint heat signatures hinting at a stellar nursery hidden behind the fiery facade. So while this nebula might look like destruction incarnate, it's actually a cradle, proof that even in what appears to be chaos, the universe is always building. Deep within the Orion Nebula's glowing expanse, there's a phenomenon so fleeting and bizarre, it seems plucked from a cosmic ghost story. Meet the Herbig-Haro objects, towering jets of ionized gas screaming through space at nearly 500,000 miles per hour. These aren't just random streaks in the darkness, they're the violent birth cries of protostars' newborn suns still swaddled in swirling dust, literally blasting their way into existence. Hubble's images capture these jets with chilling clarity, luminous tendrils stretching light years across the void, their tips glowing like spectral fingers. The eerie part, unlike the nebula's steady glow, objects flicker and fade within decades, vanishing as quickly as they form. That's because they're not permanent structures, but shockwaves, cosmic sonic booms created when supersonic stellar winds collide with slower-moving gas. Each collision heats the gas to tens of thousands of degrees, making it fluoresce before dissipating into the void. But here's what makes them truly extraordinary. These jets act like cosmic GPS markers, pointing directly to hidden nurseries where stars are taking their first breaths. By tracing their paths backward, astronomers have uncovered entire clusters of protostars otherwise invisible behind thick dust curtains. Some jets even reveal a haunting symmetry, with matching outflows on opposite sides, evidence of a spinning star hurling material from its poles like a runaway carousel. And just when we think we've figured them out, objects surprise us again. In Orion, some jets don't follow straight lines but zigzag erratically, suggesting their parent stars might be wobbling or even orbiting unseen companions. Others pulse like celestial lighthouses, hinting at bursts of chaotic feeding as the young stars gorge on surrounding gas. These aren't just stellar tantrums, they're vital clues to understanding how stars like our Sun first kicked free of their dusty cradles. So the next time you hear about ghostly lights in space, remember, the universe's most haunting specters might just be its newest stars fighting to be born. Beyond the dazzling glow of the Orion Nebula lies something far colder and far more massive. The Orion Molecular Cloud Complex isn't just a backdrop, it's the hidden engine fueling the nebula's stellar fireworks. Picture a sprawling cosmic freezer where temperatures plummet to nearly 260 degrees below zero, and hydrogen molecules huddled together in the dark. These aren't empty voids, they're dense, frigid nurseries where gravity works in slow motion, quietly compressing gas until new stars ignite. What makes this complex so fascinating is its invisibility. Peer through an optical telescope and you'll see nothing but blackness draped behind the nebula's brilliance. But switch to infrared or radio wavelengths and suddenly the void comes alive, a labyrinth of gas filaments stretching hundreds of light years, weaving through Orion like a spider's web. These dust-choked corridors absorb visible light so completely they blot out entire star clusters behind them, yet within that darkness chemistry thrives. Complex molecules like carbon monoxide and even simple organic compounds form on the surfaces of dust grains, laying the groundwork for future planetary systems. The relationship between the molecular clouds and the nebula is a cosmic tango. As newborn stars in the Trapezium Cluster blast away surrounding gas, their radiation shockwaves trigger collapses deeper in the cloud complex, sparking fresh rounds of star formation. It's a self-perpetuating cycle. Starlight destroys while simultaneously creating. And here's the kicker. Much of the Orion Nebula's stunning glow originates from just a thin outer layer, like sunlight scattering off ocean waves. The real bulk of the structure, the heavy, star-forming machinery, that's all hidden in these cold, dark depths, waiting to be revealed by telescopes that see the universe in heat signatures rather than light. This invisible architecture doesn't just shape Orion, it mirrors how star birth unfolds across galaxies. Every glittering nebula we admire likely has its own shadowy counterpart, a molecular foundation too cold to shine but too vital to ignore. So while our eyes are drawn to the neon glow of ionized gas, the universe's real work often happens in the places we can't see. Hidden in the heart of the Orion Nebula lies a celestial crime scene, a region astronomers call the BNKL Nebula, where something violent and catastrophic erupted 5 centuries ago. Infrared telescopes peel back the veil, revealing a scene of pure chaos shockwaves rippling outward at over 100,000 miles per hour, chunks of gas flung into space like debris from a cosmic demolition. This wasn't a slow, natural process. Something exploded here. The leading theory, a high-speed stellar collision 2 or even 3 young stars, each just a fraction of our sun's age, careening into one another in a gravitational misstep. The aftermath was apocalyptic. The energy released would have outshone the entire nebula for weeks, scattering scorched gas across light years. Today, we see the remnants tendrils of silicon monoxide glowing in infrared, the telltale signature of a shockwave frozen in time. Even now, knots of gas still scream outward at breakneck speeds, carrying the fingerprints of that ancient catastrophe. But the real puzzle isn't just the explosion, it's what survived. Amid the wreckage, one star, Source I, orbits the epicenter at a suspiciously precise angle, as if it were flung clear while its siblings met a fiery end. Its motion suggests an unthinkable scenario, a runaway stellar breakup where gravitational slingshots sent stars hurtling in opposite directions. Think of it as a cosmic game of pool where the cue ball smashes the rack, except here the balls are newborn suns and the table is a nebula. Yet the most fascinating detail might be the timing. 500 years ago, humanity was mapping the first oceans, oblivious to the fact that a stellar cataclysm visible from Earth had our telescopes existed was unfolding in Orion's sword. It's a humbling reminder. The universe writes its dramas on scales we're only beginning to witness, and in this case the evidence is still racing outward, waiting for us to decode its full story. Scattered like cosmic frisbees throughout the Orion Nebula, proplyds short for protoplanetary disks, offer us a rare glimpse into the earliest stages of solar system formation. These swirling rings of dust and gas aren't just beautiful, they're the raw blueprints for future planets. Each one surrounds a young star, feeding it material while simultaneously serving as a construction site for worlds yet to be born. Hubble's images reveal them in astonishing detail, some glowing like halos, others casting long, dark shadows against the nebula's bright backdrop. But what's truly remarkable isn't just their existence, it's how differently they react to their violent surroundings. Take the ones closest to the Trapezium Cluster's ferocious stars. Their fate is brutal. The unrelenting ultraviolet radiation acts like a celestial blowtorch, stripping away their outer layers in great plumes of evaporating gas. These doomed proplyds resemble comets, with vast tails streaming behind them, material being ripped away before it can ever coalesce into planets. Yet, even as they're being dismantled, they teach us something profound. Not all protoplanetary disks survive long enough to form solar systems like ours. Some are simply too exposed, too vulnerable to their stellar neighbors' wrath. Then there are the luckier ones, disks tucked further away in quieter corners of the nebula, shielded from the worst radiation. These have a fighting chance. Over millions of years, dust grains within them will collide, stick together, and gradually build the seeds of future worlds. Infrared observations reveal complex structures within some disks, gaps where fledgling planets may already be clearing paths as they orbit. It's a humbling thought. Right now, in Orion, planetary systems are taking shape in ways that could mirror our own solar system's infancy. What makes proplyds so invaluable is their diversity. Some are edge-on, appearing as thin dark slits. Others face us head-on, their concentric rings resembling cosmic bullseyes. Each perspective offers new clues about how quickly planets form, what ingredients they start with, even how common Earth-like worlds might be across the galaxy. And while many will succumb to the nebula's harsh environment, their brief, glittering lives are rewriting our understanding of how chaos gives way to order in the cosmos. These aren't just disks of debris, they're the cradles of tomorrow's worlds. Among the Orion Nebula's many enigmas, one of the most elusive isn't something we can see, it's something we can only map through its ghostly fingerprints. Magnetic fields weave through this stellar nursery like invisible threads, sculpting gas, guiding star birth, and defying expectations at every turn. For decades, these forces remained hidden, detectable only by the subtle tug they exert on particles or the way they polarize starlight, until radio telescopes finally pulled back the curtain. Observations from facilities like the Atacama Large Millimeter Array reveal a startling reality. The nebula's magnetic fields aren't just background noise. They're active players in its chaos. Delicate filaments of ionized gas align along these unseen lines like iron filings near a magnet, while newborn stars seem to spin in preferred orientations, their disks tilted as if nudged by some cosmic hand. Even the famed Orion Bar, that fortress of dust-resisting stellar radiation, its resilience might owe less to density and more to magnetic reinforcement, an invisible skeleton holding the structure together against impossible odds. But the real shock comes from scale. These fields stretch hundreds of light years, connecting regions that otherwise appear unrelated. Some areas show fields so tightly wound they resemble cosmic spaghetti, while others fan out in graceful arcs, as if the nebula itself breathes along magnetic contours. Theorists scramble to explain how such complexity emerges, but one thing's clear: without these forces, the Orion Nebula as we know it wouldn't exist. Here's where it gets even stranger. While magnetism typically weakens with distance, Orion's fields maintain surprising strength even in its outermost fringes, hinting at mechanisms we don't yet grasp. Some speculate turbulent star formation generates fresh fields like a dynamo, while others propose they're ancient relics, frozen into the gas when the nebula first formed. Whatever their origin, their influence is undeniable. They channel stellar winds, funnel collapsing gas, and perhaps even determine which protostars survive their violent births. The lesson: much of the universe's most critical architecture doesn't glow or reflect light. It hides in plain sight, written in forces we're only learning to read. And in Orion, every magnetic twist offers a new clue to how chaos gives way to cosmos. Amid the Orion Nebula's radiant glow, there's an intricate web of shadows, twisting ribbons so dense they swallow starlight whole. These are the dark lanes, mysterious filaments of cosmic dust that stretch across the nebula like veins through marble. To the naked eye, they might seem like mere voids, but peer closer and you'll uncover their secret. These aren't empty spaces. They're frigid factories where the universe's next generation of stars is quietly taking shape. Each filament is a frozen highway of microscopic grains, carbon, silicon, and ice coated in complex molecules that formed in the hearts of ancient stars. Some particles are finer than smoke, while others clump together like microscopic snowballs. But their real power lies in their ability to shield. Inside these dust lanes, temperatures plummet to nearly 260 degrees below zero, creating pockets of stillness where gravity can work undisturbed. Gas collapses in slow motion, molecule by molecule, until under enough pressure, a new star flickers to life. What's astonishing isn't just their role as stellar nurseries, but their resilience. The Trapezium Cluster's searing radiation bombards these lanes relentlessly, yet their densest knots endure. Some twist into eerie shapes, hooks, rings, even braided strands sculpted by magnetic fields and turbulence like clay on a potter's wheel. Infrared telescopes reveal hidden structures within them, tiny globules dubbed dust eggs, each potentially cradling a protostar in its earliest, most fragile state. But the real magic happens in their chemistry. On the surface of each dust grain, atoms link up to form water, carbon monoxide, and even organic compounds like methanol. It's a cosmic assembly line where the raw ingredients for future planets, and perhaps life itself, are forged in darkness. When these lanes finally fracture under the weight of their own collapse, they'll release not just new stars, but the building blocks of solar systems. So while the Orion Nebula's brilliance grabs our attention, its shadows hold the deeper story. These dark lanes are more than obstacles to light. They're the universe's way of turning chaos into creation, one dust grain at a time. And somewhere in their icy depths, the next Orion might already be stirring. The Orion Nebula plays a cosmic game of hide and seek depending on how we look at it, because not all light is created equal. Hubble's iconic visible light images show those ethereal curtains of gas, but switch to X-ray or infrared, and suddenly an entirely different nebula emerges. It's as if we've peeled back layers of a celestial onion, each wavelength exposing secrets the others can't touch. X-rays slice through the nebula's glow like a surgical tool, pinpointing young stars in the throes of violent tantrums. These aren't the serene points of light we see with our eyes. They're dynamos spewing high-energy radiation, their coronas sizzling at millions of degrees. Some of these stars are barely a million years old, yet they crackle with the intensity of miniature quasars, their magnetic fields twisted into knots by furious rotation. Meanwhile, infrared light does the opposite. It seeps through the dust that blocks visible wavelengths, unveiling cold, dark pockets where protostars huddle like embers in cosmic ash. The most startling transformations happen in the nebula's silent zones. What looks like empty blackness in Hubble's optical images becomes, in infrared, a labyrinth of glowing filaments, rivers of warm dust flowing between stars. And near the Trapezium Cluster, ultraviolet observations expose vast, bubble-like cavities blasted open by stellar winds, structures completely invisible in other wavelengths. Even the famous Orion Bar shifts identities. Once a stark wall in visible light, it dissolves into a frenetic dance of molecules under radio telescopes, where carbon monoxide and water vapor trace its hidden skeleton. This isn't just about pretty pictures. Each wavelength tells a different chapter of the nebula's story. X-rays reveal violence, infrared whispers of birth, and radio waves map the freezing highways between stars. Together, they prove a humbling truth. The universe never shows its full face at once. To truly know Orion, we must gaze at it through every lens, and even then, it keeps some mysteries tucked just beyond sight. The Orion Nebula is a cosmic fireworks show bursting with newborn stars, violent collisions, and enough energy to light up a galaxy. But there's something conspicuously absent from this chaos, the aftermath of a supernova. Given its frenzied star formation, you'd expect at least a few massive explosions littering the nebula. So where are the remnants? Why hasn't Orion's history been punctuated by the violent deaths of its most massive stars? One compelling theory suggests Orion might actually be too young for supernova. While it's true the nebula is churning out stars at a breakneck pace, the most massive ones, those destined to explode, take the longest to mature. It's like waiting for a pressure cooker to blow. These giants burn through their fuel quickly in cosmic terms, but even so, some of Orion's heaviest stars might still be tens of thousands of years away from their grand finale. But not everyone's convinced. Another camp argues we might have just missed the evidence. Supernova remnants don't stick around forever. They fade, dissipating into the interstellar medium over millennia. If a star did explode here, say, 100,000 years ago, the traces could have already vanished, swept up in the nebula's churning gas. There's also the possibility that the explosion's shockwaves triggered more star formation, effectively erasing their own fingerprints by sculpting new structures. Then there's the wild card. What if Orion's massive stars don't go supernova at all? Some models suggest the most colossal stars might collapse directly into black holes without the traditional fireworks, skipping the explosion phase entirely. If that's the case, Orion wouldn't just be missing supernova, it'd be hiding their silent replacements in plain sight. Yet the most intriguing clue might come from beyond Orion itself. Nearby regions like the Lambda Orionis ring show signs of ancient blasts, hinting that our nebula could be sitting in a supernova shadow, where older explosions cleared the area before Orion's current stars even formed. So while it looks like a quiet neighborhood now, the truth might be far more explosive. We just arrived too late to witness it. The absence of supernova here isn't a mystery. It's a timestamp revealing just how young and how fleeting this stellar nursery really is. Firing through the Orion Nebula like cosmic artillery, there's a phenomenon so violent it defies logic: tight, high-speed jets of gas dubbed bullets. These aren't your typical stellar winds. Each projectile tears through space at mind-numbing speeds, up to 250 miles per second, blasting material outward in perfectly collimated streams. What's shocking isn't just their velocity, but their precision. Some stretch half a light year long, yet remain pin straight, as if some celestial marksman took careful aim. So where do these bullets come from? Deep within the nebula's dust-choked core, newborn stars still swaddled in gas are likely the culprits. As these young stellar objects voraciously feed, they don't just consume, they regurgitate. Magnetic fields channel excess material into narrow beams, launching it outward along their rotational poles like cosmic pressure valves. The result: hypersonic jets that punch through surrounding gas, leaving glowing bow shocks in their wake, telltale sonic booms, heating the nebula's hydrogen to thousands of degrees. But here's the twist: not all bullets behave the same. Some fragment mid-flight, their tips breaking into eerie, glowing knots. Others curve unexpectedly, hinting at unseen gravitational tugs from hidden companions. The most astonishing part: we're witnessing these events in near real time. Over just 2 decades, Hubble captured one bullet's movement racing across space fast enough for human eyes to track its progress between images. These jets aren't just spectacular, they're critical to stellar evolution. By ejecting excess energy, young stars stabilize themselves, avoiding catastrophic spin-up that could tear them apart. And as bullets plow through the nebula, they sweep up material, potentially triggering new rounds of star formation in their wake. It's a chaotic feedback loop. Stars create bullets, bullets shape gas, gas births more stars. So next time you gaze at Orion's serene glow, Remember, hidden in that beauty is a shooting gallery of cosmic proportions, where the universe itself is both sniper and sculptor. Buried beneath the Orion Nebula's luminous facade lies an entire population of stars we never knew existed, invisible to optical telescopes, but blazing brightly in infrared. These aren't just hidden gems, they're game changers in how we understand the nebula's energy dynamics. While Hubble's iconic images capture the glittering Trapezium Cluster, the James Webb Space Telescope peels back the dusty veil to reveal a parallel universe of stars shrouded in cosmic cocoons. What makes these infrared-only stars so extraordinary is their stage of life. Many are protostars still in the throes of formation, so young they haven't yet ignited hydrogen fusion. Instead, they glow with the latent heat of collapse, their gravitational energy converted into warmth as they squeeze tighter under their own weight. JWST keen infrared eyes spot their faint signatures, crimson smudges nestled inside thick dust envelopes, some no larger than our solar system, but already weighing several times more than our Sun. But here's the twist. These obscured stars contribute far more to the nebula's energy budget than their faintness suggests. Their radiation, absorbed and re-emitted by surrounding dust, indirectly heats the entire region. Some even drive massive outflows, jets punching through their dusty shrouds, adding turbulence to the nebula's already chaotic gas. Without infrared scrutiny, we'd miss entire chapters of Orion's story, including the possibility that these hidden heavyweights shape the nebula as much as their visible siblings. The most startling revelation: some of these stars appear to be failed versions of the trapezium's giant objects that grew massive enough to influence their surroundings but never quite achieved the luminosity expected for their size. Whether stunted by dust or simply still gathering fuel, their existence forces us to rethink how stars allocate energy during formation. And then there are the outliers, mysterious infrared points flickering unpredictably. Some dim and brighten over weeks, hinting at eclipses by orbiting debris or violent accretion episodes. Others sit motionless, their light too red even for typical protostars, whispering of exotic possibilities like binary mergers or premature quenching. Every new infrared detection rewrites the nebula's energy ledger, proving that what we see in visible light is just the tip of Orion's fiery iceberg. So while the naked eye admires the nebula's glow, the real action unfolds in the shadows where stars are born and hidden in plain sight. At first glance, one of the Orion Nebula's most enchanting features seems simple: its ethereal green glow swirling through the gas like celestial watercolor. But this isn't just artistic flair. It's a cosmic detective story where light, chemistry, and technology collide in ways that fool even seasoned astronomers. The secret lies in oxygen specifically, ionized oxygen atoms that have lost 2 electrons under the Trapezium Cluster's relentless ultraviolet assault. When these atoms recapture electrons, they emit light at a very specific wavelength, 501 nanometers, a shade of green that dominates certain Hubble images. But here's the catch: our eyes barely register it. Human vision perceives this emission as a faint teal, almost white. So why do photos scream emerald? The answer lies in the cameras themselves. Modern telescopes use filters to isolate chemical signatures, and the ones targeting oxygen's glow happen to amplify its hue dramatically. Combine that with the way digital sensors process color, and you get a radiant green that's more enhanced reality than pure astrophysics. It's not deception, it's science prioritizing data over aesthetics, turning invisible intensities into visible beauty. Yet the story gets stranger. Some green zones in Orion aren't oxygen at all. Long exposure shots reveal methane and complex carbon molecules fluorescing in similar shades, their signatures overlapping like tangled brushstrokes. And in regions where stellar winds slam into cold gas, shockwaves can excite hydrogen to emit a turquoise tint that cameras blend into the green symphony. This chromatic illusion teaches a vital lesson. the universe doesn't have a true color palette. Every image we see is a translation, a dialogue between physics and the tools we use to interpret it. So while the nebula's verdant glow might be a technological quirk, it's also a reminder. Sometimes the most mesmerizing cosmic secrets hide in plain sight, disguised as artistry. Imagine the worst storm you've ever seen. Now multiply its fury by 1,000,000. Strip away the rain and clouds, and replace them with superheated gas screaming through space at incomprehensible speeds. This isn't science fiction, it's everyday weather in the Orion Nebula. Here, the wind doesn't rustle leaves, it shreds molecular bonds, and storms aren't measured in days but millennia. At the heart of this chaos lies a brutal interplay of forces. The nebula's massive young stars act like celestial jet engines, blasting out charged particles at speeds topping 1,000 kilometers per second, enough to race from Earth to the Moon in under 7 minutes. These aren't gentle breezes but hurricane-force gales, carving cavernous voids in surrounding gas and triggering shockwaves that ripple across light years. The result, a cosmic tempest where temperatures swing from near absolute zero to millions of degrees within mere astronomical units. Hubble's time-lapse observations reveal the violence in motion. Vast arcs of gas writhe like living things, their shapes morphing over years as stellar winds pummel them from multiple directions. Some regions resemble Tornado Alley, with twisted filaments spinning off turbulent eddies. Others show eerie bubble structures, the aftermath of ancient stellar outbursts frozen in expanding shells. And just like terrestrial storms, these upheavals aren't random. They follow patterns, with denser gas resisting erosion like mountains diverting a hurricane, while thinner clouds get obliterated like sandcastles at high tide. What makes this turbulence truly mind-bending is its scale. A single gust could swallow our entire solar system, and the energy involved dwarfs all earthly weather combined. Yet within this maelstrom, there's unexpected order. Magnetic fields channel the chaos like invisible railroad tracks, guiding shockwaves into bizarrely geometric shapes. Some gas clouds even exhibit weather fronts, distinct boundaries where hot and cold regions clash, sparking brilliant flashes of emission. For astronomers, Orion's extreme climate isn't just spectacle, it's a laboratory. By studying how gas behaves under such punishment, we glimpse processes shaping galaxies across the universe. Every shockwave teaches us how stars redistribute matter, and every turbulent eddy hints at how solar systems like ours might have emerged from similar chaos. So next time you hear a storm warning, remember, compared to the Orion Nebula, even our planet's worst tantrums are whispers in a hurricane. Deep within the Orion Nebula's swirling chaos, an extraordinary alchemy unfolds, one that transforms barren dust grains into cradles of water, molecule by molecule. This isn't just vapor drifting through space, it's a cosmic assembly line crafting one of life's most vital ingredients under conditions we once thought impossible. The process begins in the nebula's darkest, coldest pockets, where temperatures plummet hundreds of degrees below zero. Dust grains, microscopic flecks of silicon and carbon, drift like frozen motes, their surfaces pockmarked by eons of stellar winds. But these aren't passive bystanders. When oxygen atoms collide with them in the void, something remarkable happens. Hydrogen, abundant in the nebula's gas, latches onto the oxygen, bonding in minuscule steps to form water ice, one molecule at a time. It's a painstaking dance, requiring just the right mix of cold stillness and gentle chemistry. Here's where it gets fascinating. Telescopes like Herschel have detected the spectral fingerprints of this water not as liquid or steam, but as ice clinging stubbornly to dust grains. Some estimates suggest these icy coatings could contain thousands of times more water than all of Earth's oceans combined. And Orion isn't unique. It's just the closest laboratory we have to study this universal process. But water's journey doesn't end there. When newborn stars ignite nearby, their heat blasts these icy grains, releasing water vapor into surrounding gas clouds. Some get swept into protoplanetary disks, the raw material of future solar systems, while the rest is shattered by radiation, only to reform again elsewhere. It's a cycle as old as the galaxy itself, destruction and rebirth, with water as both product and fuel. The implications ripple far beyond Orion. If this nebula can churn out water so efficiently, then the building blocks of life might be far more common in the universe than we ever imagined. Every droplet forged here is a clue, a whisper that when planets eventually coalesce around these stars, they could inherit oceans ready to spark life anew. So while Orion's water factory might seem like a small detail in a grand nebula, it's proof that even in the harshest cosmic environments, the universe is quietly preparing for what comes next. The Orion Nebula's serene beauty hides a violent secret, one that only reveals itself in the high-energy scream of X-rays. While optical telescopes capture its pastel glow, NASA, a Chandra X-ray observatory, peeled back the curtain to expose something far more explosive. Young stars unleashing tantrums so fierce, they outshine our sun's largest solar flares by 10,000 times. These aren't gentle flickers, they're cosmic detonations erupting with enough force to strip atmospheres from nearby planets, if any dared to form so close. What makes these X-ray outbursts so shocking is their source. The Trapezium Cluster's stars, barely 1 million years old, should be too young for such violent activity. Yet Chandra's data shows their coronas sizzling at tens of millions of degrees, crackling with magnetic loops that snap like overstretched rubber bands. Each eruption hurls charged particles across space, superheating surrounding gas and etching intricate patterns into the nebula like invisible lightning. Some flares last mere hours, while others rage for days, a reminder that stellar infancy isn't a quiet affair. But here's the twist: these X-rays might be more than just stellar drama. They could hold the key to how planets survive their chaotic birthplaces. Radiation this intense should sterilize protoplanetary disks, blasting away the raw ingredients for worlds before they can fully form. Yet somehow, against all odds, some disks endure. Scientists speculate magnetic fields might act like shields, diverting the worst of the barrage. Or perhaps the flares themselves trigger chemical reactions that harden dust grains, making them more resistant to destruction. The most mesmerizing detail: these X-ray fireworks aren't random. They follow rhythms, pulsing in semi-regular cycles that hint at underlying magnetic dynamos far more complex than our sun's. Some stars even exhibit synchronized flares, as if connected by invisible threads across light years. It's a brutal ballet of energy, one that forces us to rewrite the rules of how stars grow up. So while the Orion Nebula's visible light paints a portrait of celestial grace, its X-ray heartbeat tells a different story, one of tempests, resilience, and the untamed fire of youth. In the deepest, coldest corners of the Orion Nebula, where temperatures plunge to nearly absolute zero, something remarkable stirs in the darkness. This isn't just empty space, it's a chemical factory, brewing molecules so complex they blur the line between space and life itself. Nestled within those icy dust lanes, far from the nebula's blazing stars, telescopes have detected frozen cocktails of organic compounds, methanol, formaldehyde, even the building blocks of sugars. These aren't simple gases. Methanol, a cousin to Earth's antifreeze, clings to dust grains like frost on a windowpane. Nearby, chains of carbon atoms snake through the void, forming molecules like vinyl alcohol, a compound that, under the right conditions, could evolve into something far more intricate. It's as if the universe is running its own chemistry experiment, one where the cold isn't a barrier but a catalyst. Without the blistering radiation tearing molecules apart elsewhere in the nebula, these frigid zones become cosmic refrigerators, preserving ingredients for billions of years. What makes this discovery so tantalizing is what it implies. These molecules aren't random, they're precursors, the same kinds of compounds that might have seeded Earth's oceans with the raw materials for life. Some regions even show traces of methyl formate, a molecule once found in comets, suggesting these frozen caches could hitch rides on asteroids to newborn planets. The Orion Nebula isn't just a stellar nursery, it's a pantry stocked with the universe's most essential recipes. Yet the real magic lies in how these molecules form. Ultraviolet light from distant stars, too weak to destroy but just strong enough to energize, triggers reactions on dust-grained surfaces. Atoms shuffle and bond in the dark, assembling like microscopic puzzle pieces. When the James Webb Space Telescope peered into these frozen vaults, it spotted chemical diversity rivaling Earth's laboratories, proof that the universe doesn't need warmth to craft complexity. So while the Trapezium Cluster's brilliance grabs headlines, Orion's silent, frozen zones might hold its most profound secret: the quiet, relentless chemistry that turns stardust into the seeds of life. Every icy grain here is a time capsule, carrying whispers of how life's building blocks spread across galaxies, one frozen molecule at a time. Rising like a frozen tidal wave against the Orion Nebula's glowing currents, the stellar spire stands as one of nature's most breathtaking sculptures. At first glance, this 7-light-year-tall tower of dust and gas might remind you of the Eagle Nebula's legendary pillars of creation, but don't be fooled. This celestial skyscraper has a survival story all its own. Where Hubble's famous pillars face imminent destruction from newborn stars, the stellar spire endures, weathering its stormy environment with astonishing resilience. The secret lies in the spire's slower, more methodical erosion. Unlike its Eagle Nebula counterpart, which is being vaporized by intense radiation at a visible pace, Orion's spire benefits from a crucial buffer. Its densest knots of gas act like cosmic armor, deflecting the Trapezium Cluster's brutal stellar winds. Meanwhile, the structure's base remains shielded by intervening dust lanes, buying time millions of years, in fact before the inevitable collapse. Infrared observations reveal hidden protostars buried within these protective layers, silently gathering mass while their nursery resists demolition. But what truly sets the spire apart is its eerie geometry. While many cosmic structures crumble unevenly, this one maintains a near-perfect blade-like edge, as if sculpted by an unseen hand. Theorists suspect magnetic fields play a role, channeling radiation around the spire like an invisible force field. Others point to its unique orientation, angled just enough to let destructive energies glance off its surface rather than strike head-on. Yet for all its defiance, the spire isn't immortal. Hubble's time-lapse images show faint wisps of gas peeling away from its crest, a reminder that even the mightiest cosmic formations must eventually yield. But here's the beauty: this gradual erosion might actually be fostering new star birth. As material is stripped from the spire's outer layers, shockwaves compress inner pockets of gas, triggering fresh rounds of stellar ignition. So while the Eagle Nebula's pillars may claim fame, the stellar spire offers something equally valuable: a masterclass in cosmic persistence. It's not just a monument to destruction. It's proof that even in the universe's most chaotic neighborhoods, structures can carve out their own timelines, bending the rules of stellar evolution along the way. Not every star in Orion's grand nursery stays put. Some get flung into the void like cosmic outcasts, racing away at speeds that defy imagination. These are the runaway stars, stellar renegades ejected from their birthplace with such force they'll never return. And Orion's nebula is one of the most prolific launch pads for these interstellar fugitives. Take, for instance, the star Orion, currently speeding through space hundreds of light-years from where it began. This blue-hot maverick didn't leave willingly. It was catapulted by gravitational chaos. Here's how it likely happened. Millions of years ago, a close encounter between multiple massive stars in the Trapezium Cluster turned into a celestial game of pinball. When two stars swing too close, their gravitational embrace can slingshot one outward at breathtaking velocities, sometimes exceeding 100 kilometers per second. That's fast enough to cross the entire United States in under a minute. But Orion isn't alone. Mu Columbi and 53 Arietes are also confirmed runaways, their trajectories tracing back directly to Orion's turbulent heart. These stars don't just drift, they scream through space, leaving glowing bow shocks in their wake as they plow through interstellar gas. The aftermath resembles a speedboat's wake, but on a scale so vast it stretches light years. What's fascinating isn't just their speed, it's what they carry with them. Some runaways tow remnants of their protoplanetary disks, dragging potential planet-forming material into the cosmic wilderness. Others, stripped bare by the violent ejection, blaze as exposed stellar cores, their outer layers ripped away in the chaos. Yet the most tantalizing question remains: could these stellar exiles harbor planets? If so, those worlds would endure the most extreme journey imaginable, orphaned from their birth nebula, hurtling through the galaxy's void, lit only by a star that was itself exiled. It's a reminder that even in the seeming order of the cosmos, chaos always has the final word, scattering stars like seeds in the wind. The Orion Nebula's brilliance often steals the spotlight, but hidden in its outskirts lie ghostly remnants of past violence, vast, hollowed-out bubbles frozen in time. These aren't just empty voids, they're cosmic fossils etched into space by titanic forces that once raged here. While optical telescopes show nothing but darkness, radio waves reveal their true forms, delicate shells stretching dozens of light years, each one a monument to ancient stellar fury. Some of these cavities were carved by long-dead stars, their final supernova explosions blasting away surrounding gas like a celestial snowplow. Others bear the quieter but relentless signature of stellar winds, streams of charged particles that, over millennia, sculpted the nebula's outer layers into fragile, balloon-like structures. What makes them extraordinary isn't just their size, but their longevity. Even after the stars that created them have vanished, these bubbles persist, their faint radio whispers telling stories of chaos that unfolded before humankind first looked skyward. Peering into one of these shells is like staring into a fossilized hurricane. The edges aren't smooth, they're jagged, rippled with turbulent fingerprints from the shockwaves that shaped them. Inside, the gas is eerily still, almost sterile compared to the nebula's churning core. Yet this emptiness is deceptive. These bubbles aren't just relics, they're active participants in Orion's ecology. As they expand, their shockwaves compress surrounding gas, triggering new rounds of star formation along their rims. It's a self-perpetuating cycle, destruction sparking creation, with each bubble acting as a catalyst for the next generation of stars. The most intriguing detail: some of these structures don't match any known supernova models. Their shapes suggest multiple, overlapping explosions, or perhaps something even more exotic, like a runaway star detonating as it fled its birthplace. Others show bizarre chemical signatures, their surfaces dusted with rare isotopes forged in stellar cores. Every shell is a time capsule, preserving clues about the nebula's violent adolescence long before the Trapezium Cluster's stars flickered to life. So while these fossilized bubbles might lack the visual drama of Orion's glowing gas clouds, they hold something far more valuable: a chronicle of the fires that shaped this stellar nursery, written in the language of radio waves and cosmic memory. And as telescopes grow more sensitive, who knows what other ancient whispers will uncover in the nebula's forgotten corners. The Orion Nebula may dazzle us today, but its future holds a startling transformation, one that will erase its glowing signature from our night sky entirely. Right now, we're witnessing this stellar nursery in its prime, bursting with newborn stars and turbulent gas. Yet in just a few million years, a cosmic heartbeat, the Trapezium Cluster's most massive stars will finish their violent work, blasting away the remaining gas like a celestial hurricane stripping leaves from trees. What remains won't be a nebula at all, but a scattered skeleton of stars, an open cluster drifting silently through the galaxy. The process has already begun. Every stellar wind, every radiation blast is carving deeper into the nebula's fragile structure, evaporating the raw material for future stars, those iconic gas pillars. They'll be the first to go, their delicate forms unable to withstand the unrelenting assault. Even the mighty Orion Bar, that cosmic fortress of dust, will crumble under the combined energy of its neighboring stars, its molecules torn apart atom by atom. But here's the twist: this destruction isn't the end, it's a metamorphosis. As the nebula's gas dissipates into the void, the trapezium stars will finally stand unveiled, their brilliance no longer diffused by glowing hydrogen. Freed from their dusty cocoons, they'll drift apart over eons, pulled by galactic tides and subtle gravitational nudges from passing stars. The tight-knit family we see today will become solitary wanderers, their shared origin fading into obscurity. Yet traces of Orion's legacy will linger. The cluster's lower mass stars, those too faint to burn away their cradle, might still carry disks of debris, the last remnants of the nebula's once vast reservoir. And somewhere in the darkness, planets could orbit these stars, their atmospheres subtly enriched by elements forged in the nebula's fiery heart. So while future civilizations might gaze at Orion's belt and see only a scattering of unremarkable points of light, we're the lucky ones, alive in the brief cosmic moment when this masterpiece blazes in full glory. The nebula's fate isn't a tragedy, it's the universe's way of turning one beautiful era into the raw materials for the next. And somewhere in another corner of the galaxy, another nebula is just beginning its own dazzling and fleeting performance. For millennia, the Orion Nebula has been more than just a celestial wonder, it's been a canvas for human imagination. Before telescopes even existed, ancient cultures wove its glow into their myths. The Maya saw it as the cosmic hearth of creation, the fiery heart of a celestial turtle. To the Egyptians, its position in Orion's sword mirrored the gateway to the afterlife, a path traced by the soul of Osiris. Even Aboriginal Australians incorporated its shimmer into Dreamtime stories, marking it as a hunter's campfire in the sky. This nebula wasn't just observed, it was felt, a constant in humanity's quest to find meaning among the stars. Then came Galileo. In 1610, his crude telescope revealed something revolutionary. What the naked eye saw as a single fuzzy star was actually a nebulous smear, a phrase scribbled beside history's first recorded sketch of the nebula. That moment didn't just change astronomy, it shattered humanity's understanding of the heavens. Suddenly, the universe wasn't a static tapestry. It was dynamic, messy, alive with processes far beyond earthly scale. Over centuries, each advance in technology peeled back another layer. William Herschel's detailed mappings, Hubble's iconic photos, Webb's infrared revelations. Every era's tools transformed the nebula from a mystery into a classroom, teaching us how stars are born, yet its influence stretches far beyond science. Science fiction authors from H.G. Wells to Arthur C. Clarke set cosmic adventures against its glowing backdrop. Film directors framed it as both destiny and danger. The nebula's ethereal glow featured in 2001, A Space Odyssey, and Star Trek as a symbol of the unknown. Even musicians channeled its grandeur. Vangelis composed an entire album inspired by its Hubble portraits. This interplay of art and science speaks to something deeper. The nebula isn't just an object in space. It's a mirror reflecting humanity's endless curiosity. Today, as amateur astronomers point their backyard telescopes toward Orion's sword, they're participating in a tradition as old as civilization itself. The same glow that guided ancient navigators now inspires Instagram posts, classroom lessons, and cutting-edge research. Whether as myth, muse, or laboratory, the Orion Nebula remains one of the few cosmic landmarks that transcends culture and time, a reminder that the universe doesn't just belong to scientists. It belongs to storytellers, dreamers, and anyone who's ever looked up and wondered. If you've ever wanted to witness the Orion Nebula's glow with your own eyes, you're in luck. This cosmic wonder isn't just for professional astronomers. Even a simple pair of binoculars can reveal its ethereal haze, hanging like a celestial jewel beneath Orion's belt. The best part, you don't need high-tech gear or perfect conditions, just a little know-how. First, timing is everything. Orion dominates winter skies in the northern hemisphere, rising high by mid-evening from late November through February. Head outside on a moonless night, away from city lights, and let your eyes adjust for at least 20 minutes. The nebula sits in Orion's sword, that faint line of stars dangling south of the belt. To the naked eye, it might look like just another blurry star, but point your binoculars there and suddenly the blur resolves into something magical, a misty patch glowing with an almost ghostly light. For an even clearer view, a small telescope, even a basic model with a 3-inch aperture, unlocks stunning details. At low magnification, you'll spot the nebula's sprawling wings, while higher zoom might reveal the Trapezium Cluster's 4 brightest stars, twinkling like diamonds set in fog. Pro tip: use averted vision. Look slightly to the side of the nebula instead of directly at it. Our peripheral vision picks up faint light better, making the nebula's delicate tendrils pop. Patience pays off. The longer you observe, the more your eyes will detect subtle structures, dark lanes cutting through the glow, or hints of the surrounding gas field. And if you're sketching what you see, over time you'll notice how the nebula's appearance shifts with atmospheric conditions, sometimes crisp, sometimes hazy, but always alive. No matter how you choose to observe it, the Orion Nebula offers something rare, a direct link to the cosmos, no filters or processing required. Every glance through the eyepiece connects you to centuries of stargazers who marveled at this same sight, and to the nebula itself, where stars are being born even as you watch. So wrap up warm, step outside, and let your own eyes bridge the distance between Earth and those distant glowing clouds. The universe is waiting. From ghostly jets of newborn stars to the explosive aftermath of ancient stellar collisions, the Orion Nebula has proven itself a universe of wonders packed into a single cosmic cloud. We've journeyed through 25 of its strangest marvels, each one defying expectations, from the relentless erosion of the Horsehead Nebula to the invisible magnetic threads weaving order into chaos. Who would have thought a single stellar nursery could harbor such drama? Yet what's truly staggering isn't just the individual phenomena, it's how they intertwine. The nebula's brilliance depends on its shadows. Its destruction fuels creation. Those flickering Herbig-Haro objects point to hidden stellar births, while the Trapezium Cluster's fury simultaneously tears gas apart and compresses it into future stars. Even the missing supernova tell a story, hinting at a timeline we're only beginning to piece together. This isn't just a snapshot of deep space, it's a living, breathing ecosystem. Every dark lane, every infrared whisper, every bullet-like jet adds another layer to our understanding of how stars, and perhaps planets, are born. And the best part: this cosmic laboratory sits right in our celestial backyard, close enough for backyard stargazers to witness its glow. Now it's your turn. Have you spotted the Orion Nebula through a telescope or binoculars? Maybe you've captured its glow in a photo, or you're left with burning questions after today's deep dive. Drop your thoughts in the comments. We're all part of this never-ending exploration, from ancient mythmakers to modern scientists. After all, the universe doesn't just reveal its secrets to experts, it invites every curious gaze. So keep looking up. Who knows what mysteries we'll uncover next?